Well, thank you for joining me on exercise 2A. I'm looking at 1 part B. So this is 1 part B, and it says to copy the following graphs, then draw the first derivative and the second derivative for each one. So I've tried to copy that graph as best I can, and let's have a look at these points. Now, the first derivative describes the behavior or the rate of change of the function. So let's have a look at, first of all, where is the function? If we were to say, well, when the function has turning points and the rate of change is 0, the gradients are 0, that means the first derivative will be 0. And when the, I'll just put that, when the turning point is, the gradients are 0, I'll use red, the gradients be 0, and then blue when the function is, when f of x is increasing in rate of change, the first derivative will be a positive, and when the function's decreasing, the rate of change is negative. The rate of change is a negative value. So let's have a look at first the turning points. Now there's a turning point there, there's a turning point there, there's a turning point there, and it levels out just momentarily here. It sort of gets this 0 value there, and that's got a gradient of 0. So the tangents, if we looked at the tangents, they're all horizontal. So for that x value, we will have a 0 value. For this x value, we will have a 0 value. For this x value, we have a 0 value, and for this x value, we have a 0 value. Now, when the gradients are, when the function is increasing here, we've got a positive gradient, and the gradients are actually getting smaller, and so they're positive. And the gradients here are positive again, and it's steepest at this position here. And let's just draw that. Try to get that. It's steepest at this position here, and that's where the tangent crosses through the curve, and so it's going to be going up and then going up and down, so the steepest at that value there, and there's nowhere else it's positive. So we've got a negative slope here, and the steepest it's negative is at this point, which is, these are called point of inflections. That's like the middle of the S bend. So at these points, point of inflections, it's the most negative. So for that x value, it's the most negative here. And then we've got a negative slope, and that's the most negative at this point of inflection. And so it's, and then we've got again, it's going to start going negative again. So it's going to start going like that. That's difficult. Okay. Negative. Back to steep. Okay, let's put an arrow here. Now let's have a look at the second derivative. The second derivative describes the behavior of the first derivative. So if the rate of change is negative, it's coming down, and it's still coming down to this point here. So at this point, we've got place where the rate of change is 0, so we'll put a 0 here. Let's just get this in sync with our graph. It was supposed to be at that point there. So we come down at the point of inflection. It's deepest here. So at that point, the gradient is 0 of our derivative. And here we have another gradient of 0, and that's happening at the point of inflection of our function. So we have another 0 second derivative. And we've got another turning point here, and that happens at our point of inflection on our function. So there's a 0 value there. And here we've got another 0 value at this point of horizontal inflection. So there is another 0 value there. And the graph is going up, so it'll be positive between this turning point and this turning point. It's going up, and it's steepest at this point here. So we're going to up and then down, that's positive. And there's another positive gradient between here, and it's steepest there, so it's like a little curve there. And we've got negative slopes all the way down here. So we've got negative slopes, and we've got a negative slope between this turning point and this turning point. And it's going to be steepest at this point of inflection on the function. And then we're back to negative here. So positive, and now we've got a negative. All right. One, 2, 3, 4. It's positive. 1, 2, 3. Well, I think we'll leave it at that. I hope that's correct, and I hope this has helped. Until